Hello, and welcome to Using Your Math Curriculum Virtually. In this module, we'll discuss student-directed learning. I'm Melinda Griffin, a researcher at American Institutes for Research, and I'm a member of the Rhode Island Intensive Math Intervention Project. I'll be your guide during this series. We have created a series of mini modules to help you think through how to teach math virtually. In the previous model, we discussed planning lessons for distance learning. In this module, we will think through options for independent learning that is student-directed. I'll be using the terms virtual learning and distance learning throughout this session. There is a distinction between this and online learning. Online learning is planned to be delivered virtually from the start, whereas distance learning, we'll be adapting what we normally would use with students in the classroom to a virtual environment. Throughout this series, we followed some guiding principles. Try to use what you've already been using because what's familiar will be easier for you and your students. Remember to keep it clear and simple, and we're working to combine new learning with keeping skills sharp. Make sure your plan works for all families, thinking through how your students will receive and give back to you their learning. And remember, this is not a solo endeavor. You should definitely be working with teammates and colleagues during this process. So let's get started thinking about student-directed learning. In this module, we're going to consider math learning activities that students will do at home, independent of the teacher and their classmates. We need to consider our purpose in assigning this work, our expectations for the work that students will submit, logistics for making sure students and parents are clear on what and how to do the assignments, and supports that we need to put in place to help our students be successful. So before we dive into specifics, there are some general issues to keep in mind. Households are chaotic right now. Entire families are stuck in the house together all the time, and this leads to competition for space, time, and bandwidth as they try to balance schedules and needs. Schedules and routines may be changing frequently, and we shouldn't forget the reason we're in this situation to start with, illness. So families may be caring for loved ones in the home or worried about elderly members who are not with them. Parents are feeling overwhelmed, and you may be feeling this right now as a parent too. Parents may be working from home, or they may still be going to work each day, or they may be working while trying to provide childcare for their younger children. Add running their children's school day on top of this, and it leads to emotional overload. They want to do what's right for their kids, but it is exhausting. An important point to remember is that students will not be able to accomplish as much on their own as they did in the classroom with you. In the classroom, a teacher communicates visually and orally with students to assess their learning and provide support. With students now doing this work apart from you, we need to consider how to support students without being physically near them. Some students may have parents or siblings who can help, but there are other students who may not. And even if students have a computer at home, they may be sharing it with other siblings or their parents who need to use it for work. We need to keep these things in mind when determining what self-directed learning is going to happen. Students need clear instructions, clear expectations, know how to submit their work, and know what to do if they need their help. And above all, you need to be flexible in these areas. In addition to all the hats you currently wear as a teacher, you'll be adding that other hat to your wardrobe, tech support. In the prior module, we learned about the components of a virtual learning lesson. We separated components into asynchronous or synchronous delivery and then looked at each in more detail. Today we're going to focus on the asynchronous portion. Students may complete a warm-up or review, watch and possibly interact with a math lesson, and they also will complete some independent practice. So let's take a look at what each of these components might look like, thinking through the logistics, content, expectations, and supports that students need in each area. To help you think through your students' independent work, we have a lesson planning template for considering supports, both virtual and otherwise, that your students will need. In our teacher-directed learning module, we discuss supports that students need for virtual learning. Students will need materials to complete work at home, so make sure you account for these when you're planning independent work. Students will also be working without the usual executive functioning cues that they receive in the classroom, so provide supports such as checklists, graphic organizers, timers, and reminders. You will also need to provide clear, simple directions for tasks, keeping in mind that students may have limited or no adult support at home. As you think through these student supports, planning the work that you're going to have students do, be sure to incorporate the principles of universal design for learning. We discussed that in more detail in Module 2. Now let's consider each of the components for asynchronous learning. My purpose for the warm-up or review is going to drive the content that I use. And I also need to decide on my expectation for when the warm-up is completed, as well as considering what my students need to know in order to do the work. Let's look at some possibilities and think about what students will get from this experience. So I might decide my purpose for the warm-up is to have students practice a lead-in skill that they need for the math lesson that's following, or perhaps review some previously learned concepts. In both of these cases, I would want students to complete this before moving on to the math lesson. This is going to let students know why is this important to what I'm learning next. Perhaps my purpose for a warm-up is to have students read to understand a math problem and make a plan for solving it. They would need to complete this before the next virtual meeting or teacher direction so that they're prepared to come to a discussion. It's important for students to know that perhaps it's okay not to solve the problem. Perhaps all you want them to do in the warm-up is think about setting the problem up, and then you'll actually work through the problem together. I might assign a warm-up for practice for fluency, and students might be able to complete this over the course of a week as opposed to just in one day. This is helping students keep skills sharp, and we want to make sure we do that as we go through this experience of virtual learning. I might assign a warm-up to practice writing or communication skills in math, and students might be able to complete this over the course of a week, or I might assign it expecting students to complete it before their next class meeting. This helps students continue to think about how do I communicate my thinking to others, which is one of the important standards for mathematical practice. Maybe I decide to assign a warm-up or review just to show how cool math is, or that students can think about how math fits into the world around us. This might be an optional type of warm-up, just something fun for kids to do, or I might assign it as something that I want my kids to explore before our next class meeting. And students should know that this is really cool, but it's okay if I don't do it. In other words, it's not essential to the math lesson that comes next, but it is an interesting way to think about how math functions in our world. Now let's consider some possible sources for warm-ups and how they fit with each of our purposes. Remember, your best option is to use something your students are familiar with, but it's okay to introduce something new occasionally too. Just don't throw too much new stuff at them at once. So one possibility is virtual number talks. And this could be really good if you were already using number talks in your classroom, so students are already familiar with it. Number talks focus on using mental math with operations and strategies. And it's great that students continue to see multiple solution strategies. We have a separate mini module on virtual number talks that's available on the website. Your published curriculum is also a rich source for warm-ups. You might choose to use a video to refresh or introduce a topic, choose a couple of review problems for your students to work, or just have students look over examples of previous content. You could also choose an application problem to help students make sense of word problems or to solve in its entirety. You can help students continue to strengthen their written communication skills in math by choosing an error analysis problem or asking students to explain their thinking or justify an answer to a problem. This would also work well for independent practice problems. You may have used a number of the day warm-up in your classroom, and you can continue this with distance learning too. This work strengthens students' number sense as they compose or decompose numbers and see multiple representations of a number, which might also include writing an algebraic expression or an application problem for the number. Another great source is the website, Which One Doesn't Belong? This has numeric and geometric puzzles for students to consider. This is a way to continue building number sense and reasoning with patterns and relationships. Having students defend and support their answer or finding a justification for all of the possibilities incorporates the standards for mathematical practice. So now let's think about the lesson itself. Your students will interact with the math lesson asynchronously, followed by reinforcement time with you, either in online sessions or by phone. The format column shows a progression from top to bottom of what to include in the lesson. Notice that this is not dependent on a platform and should be the same for either offline or online delivery. You also want to take into account what your students need to know for each one of these segments. You'll start by stating the learning outcome in kid-friendly terms, which makes it clear to students what they are learning today in this lesson. In other words, it answers, why are we here? Math tends to be a chronological progression, so tell students how any previously learned skills or concepts connect to the math they're about to learn. This helps them think about how will this math fit in with what I already know. In the classroom, we might have students discover this for themselves, but with distance learning, we need to be direct. You might also include some real-world connections to help answer the ever-present question, when am I ever going to use this? Next, you would demonstrate the skill or explain concepts while you think aloud. Students will be able to hear your thought process while they see the math unfolding, and this mirrors what you would do in the classroom by providing both visual and auditory input. Students will be able to visually follow the math while hearing you explain it, and this will help it make more sense to them. After you've demonstrated the learning outcome for students, provide a summary of what you just taught. This reiterates what they are learning and reinforces the learning outcome for the lesson. And students may go, oh yeah, that's what this was all about. Do not expect students to get there on their own. You also want to provide some worked examples to give more insight into the process that you just demonstrated. This is important for students to look at while they're doing their independent work at home, and is also great as a reference for anyone who is helping them out. So how is this lesson going to happen? We discussed in the previous module that the lesson should be available asynchronously to allow students and parents to access it when it's convenient and as many times as they need to view it. The entire lesson from start to finish should not take more than 10 to 15 minutes. And if you use videos, you want to keep them to less than 5 minutes in length. Now let's look at each of the lesson segments and think about how these might play out in an online, a hybrid, or an offline environment. You'll start the lesson by stating the learning outcome for students and explaining how today's lesson connects to previously learned math. To do this, record an introduction to the lesson that includes the learning outcome for the lesson and how it connects to what they've previously learned. This could be a video of you talking, preferably with some visuals too, which works for an online or a hybrid environment. You could also create an audio file that would work well for all three environments. For students who are only offline, create a document that states the learning outcome and explains how it connects to prior learning. You might also consider including an example too. You might combine this with a short phone call to make sure that the student has the information and understands it. Next, we'll move to the heart of the lesson, where you introduce new material, and there are numerous options here. For an online or hybrid environment, video is your best option. You could create your own, use a video from your textbook series, use a different online video created by another teacher, or a combination of you and someone else. That last option can work really well, as someone else does the heavy lifting of conveying new information, followed by you explaining it in more detail for your students with the voice and mannerisms that are familiar to them. Another option is to provide a document guiding students through the lesson and create an audio file to accompany it. For your students who are offline, check your curriculum for supplemental materials that teachers often use for remediation in the classroom. These materials are created to provide a more detailed explanation of the class lesson, which will be beneficial for independent student learning. You should also consider what is included in the student workbook, supplementing the information there as needed. For multi-language learners, providing hard copies of explanation with an audio file aids in comprehension. To close the lesson, create a slide with an audio summary of the lesson, including restating the learning outcome. This slide can be used by students in any of the three environments. For students who are offline, you could take a picture of the slide and include a written summary. Worked examples are important because this lesson is really short. So creating a slide for each worked example can be used for all three environments. With online students, they can access it via a platform, while offline students can refer to it as images. Sources for worked examples include your textbook series, other online sources, or just your class lesson notes. You could also work through a couple of problems from the student workbook, or maybe some practice sheets. You also need to think about how you will support student learning of math vocabulary. In the classroom, you would most likely call out these words directly with students while you're teaching, but externally sourced videos might not include or emphasize the words that you know your students will need. Providing access to an online glossary or a virtual word wall will help your students become familiar with the words that they need. Now let's think about the content. There are numerous sources for online content to use in your lesson. Your published curriculum is a great place to start, particularly if your students are used to seeing videos in the classroom or perhaps from other platforms such as BrainPop that they're already familiar with. Khan Academy provides high-quality, step-by-step videos. You may be able to search and find videos on YouTube that other teachers or organizations have created, particularly ones that show doing math with manipulatives. Zearn has a video library as well as student resources, and another great site is MathCuts out of the Daner Center at UT Austin. Likewise, for teacher-created content, there are many platforms to choose from. Flipgrid, Screencast-O-Matic, Loom, and Nearpod are very user-friendly for recording your own work, and some could also be used by students to record and submit their independent work. You can also record on virtual whiteboard sites, such as Miro or EduCreations, so students can follow your work. For students working offline, handwritten or typed notes are needed, or you may be able to use materials from your curriculum. You can take a picture of the materials or create a PDF that can be downloaded or viewed on a phone. Including an audio recording along with or calling a student to give a quick walkthrough of materials is also very helpful. Manipulatives are also another consideration. Whenever possible, try to have the manipulatives that appear in videos match the ones that students will use in their independent work. If students do not have access to, or you do not want them to use a virtual manipulative, include some pictures of homemade alternatives. For students who will be consistently working offline, check to see if the school can lend the student a set of manipulatives to use during this time. Closed captioning can also be added or turned on in recorded presentations. This is a great support for multilanguage learners or if students need to watch the lesson in a noisy environment. A good source as a resource for looking at all of these different platforms and tools is put out by Common Sense Education. So check out their link. So students have interacted with the warm-up and the lesson, and now they're ready to move on to some independent practice. Time is limited here as well, and you should plan on 10 to 15 minutes of independent practice related to the lesson. That means you need to be purposeful in choosing problems of a format that lends itself best to the mathematical understandings of the lesson. So here are some examples. If I'm thinking about math problems of increasing difficulty as a format, these work well for building understanding and confidence through progressively difficult work. I might also consider an interleave worked solution strategy, which is a combination of guided and independent practice. Scaffolded application problems help students learn the process of thinking through a particular type of problem. For application problems, you might want to follow a format that you already use in the classroom, such as UPS check, understand, plan, solve, and check. I might want students to do an application problem with justification. This helps our students continue to work on their communication skills by defending a solution. Error analysis is also a format that has students interpret and take a position on another person's work. I might decide to assign some games, puzzles, or other activities like that. These are often a good use for fluency because it provides students with extra practice on a previously learned skill. And I might want to use an exit ticket or an assessment, which helps me determine how to adjust my instruction in the future. So my students need to know for independent practice, what materials do I need to do this work? What am I supposed to do? What should my final work be? What do I do if I get stuck and need help? And what do I do with my work when I finish? As we discussed in Module 3, it's important to know your students' support needs, particularly for completing independent practice. Students will likely need manipulatives, at least when first learning a concept. This is also where you need to pay attention to callouts from the math standard, such as visual fraction models, so that you can make sure students have manipulatives that marry well with the concepts they are learning. For language supports, a virtual word wall or an online glossary are helpful. Creating Frayer models for math words makes a great warm-up or an independent practice tool. A short how-to video on how to access and use an app or an audio recording of directions will be very helpful for students and their parents, and a resource page with links to online timers, calculators, graph paper, etc. will also be useful. Let's also think about how you can support particular math problem formats. The interleave worked solution strategy provides additional scaffolding, similar to the I do, you do format that many teachers use in the classroom. For this strategy, a modeled problem is provided. This could be just visual or visual plus an audio, and then the student works the same type of problem independently. Having the modeled problem handy when working independently provides a reference for thinking through a solution strategy or procedure. It can also be used to reinforce schemas or task strategies that students already know. Scaffolded application problems break down an attack strategy into smaller steps to help the student think through each part of the process. The task is portioned into incremental steps with thinking prompts. Many students are fine with the math needed. It's getting to the math that's difficult. This scaffold points out what to consider when reading to understand an application problem, and then how to choose a strategy for solving it. Justifying and critiquing the work of others is a process skill featured in the Standards for Mathematical Practice. You may have provided scaffolds for this in your classroom with anchor charts or other posters that give sentence starters, so providing these as a resource and reminding your students to use them. Students will also benefit from seeing an exemplar of what a high-quality justification or critique looks like. If you assign games, puzzles, or other online activities, provide both a link to the website as well as a pin if students need to access the platform through an app. Even if they have used these activities in the classroom, students may have to access them differently at home. And don't forget to remind students and parents of needed usernames and passwords too. I'm also going to suggest a tactic that you may or may not have used in your classroom before. Give them the answers. This may freak students and parents out a bit, but it serves the purpose of relieving anxiety around, is this correct? And instead move students into thinking about the solution process and not just the outcome. Students respond by showing how to achieve the answer, and it opens the problem up to multiple solution methods. It can also provide stress relief for parents who are trying to work with their child. Independent practice is a great place to differentiate for students according to their needs. You can maintain learning outcome expectations while differentiating the content that students interact with, keeping in mind that practice time should be 10 to 15 minutes. So here's an example of the types of problems you might see on a student practice sheet from a published curriculum. The first 5 problems focus on skills. This is often by performing an algorithm precisely and accurately. This is often where you find naked math problems, consisting only of numbers, operations, and perhaps some variables. The first problem guides students through the process and is followed by 4 other problems of increasing difficulty. The next section has students applying these skills. Number 6 guides students through the application problem, followed by 3 other application problems that increase in difficulty or complexity. These are followed by an error analysis problem, another asking students to draw a model to match a given situation, and the last problem asks students to create their own problem, perhaps by writing a problem that matches a given model. So I'm going to divide these problems into several categories before assigning them to my students. I look at the problems overall and decide that all of my students need to do number 3, number 4, number 8, and number 11. Some students will benefit from doing number 1 and number 6 as lead-in problems, and some students will need additional practice by doing numbers 2 and 5. I also want to make sure that I have some challenging problems for students, which is why 9, 10, and 12 might be assigned. Now I think about my leveled groups pertaining to the topics I am teaching. In other words, these groups should be fluid and not static. Group A is going to need the most support. I'm going to meet with them online to work through number 1 and number 6 together, and then I'll assign numbers 2, 3, 4, and 8 for independent practice. I will meet with this group a second time to complete number 7 and number 11 together, possibly using an interleave work solution strategy approach. Group B also needs more teacher support. They will complete number 2, 3, and 4 to provide ample practice with the skill. I think they will struggle more with the application problems, so I assign number 6, which will guide them through the process before moving on to number 7 and number 8. We will do number 11, drawing a model to match, together as a group when we meet online after they have completed their independent work. Reviewing independent work before we meet allows me to add any supplemental problems or explanations where I see that they've had difficulty. I expect Group C to complete the skill problems easily, so I only assign number 3 and 4. I include number 7 and number 8 for application for sufficient practice, and I want them to attempt number 10 and 11 on their own. As before, I can address common errors or difficulties when we meet together as a group. Group D is my most self-sufficient group, and they will enjoy tackling challenging problems. They complete number 3 and number 4 for skill practice, and then move to number 8 and 9 for application. I'm also going to assign them number 10, 11, and 12, which are more challenging. Even though I am not assigning all of the problems to any of my students, I will give each student the full problem set because I don't want to limit their potential. This provides a resource if they need to work some simpler problems and some more challenging problems that they might be interested in and decide to try. I do need to be very clear with students and parents as to which problems I expect them to complete to avoid the perception that because they received a full problem set, they have to complete the entire set. I can also differentiate my expectations for the student-created product. This differentiation may be based on student characteristics, such as language acquisition or handwriting skill, or perhaps on technical capabilities, such as online or offline access. When possible, I want to give my students options for what the finished work will look like, perhaps listing a preference that best matches the content. Let's look at some possibilities. I might have students take a picture of their work to submit to you. This is not a picture of them actually working on the math, but rather a nice clear picture of the actual math work they did. Students can also create an audio recording or video recording to explain their work, once again making sure that I can see that math work clearly. Students might decide to act out solving a math problem by videoing themselves solving a problem using manipulatives. Another possibility is having students join in on an online discussion. This could be responding to another's work or displaying their own work and explaining it to others. I would not try this right away if your students have not done this before. I would expect my students to be working out their math so that I can see their thinking. Students could submit their paper copy directly to me, or I might decide to use an online form where students include pictures of their work, perhaps having them answer pre-populated questions in a Google form. As with assigning problems, I want to make sure I give clear instructions on what I expect student work to look like. This helps students understand the expectations and helps parents know how they can help their child. I also need to think about how students are going to get their work to me. Plan for both an online and an offline method for work submission. If students and parents are already used to a school platform, such as Google Classroom or ClassDojo, continue using what is familiar. As I've said many times before, communicate with students and parents as to due dates and how to submit the work. If you have calendar entries for due dates, see if you can include the submission link as well. And a reminder app can be very helpful for parents who are managing multiple kids in multiple grade levels. So here are some final words of wisdom to think about with independent practice. Parents do not want to see multiple worksheets, and students do not want to complete them. Be careful to not over-assign work, and try to vary it from just the usual math worksheets. You would have varied work in the classroom anyway, so try to mix it up with independent work too, so that the kids stay interested. Do not throw too many apps at students and parents. There are tons of cool technology apps out there, but each one of them requires a learning curve, and we're dealing with a lot of other stuff right now. Especially think about parents and caregivers with multiple children. Start with some familiar apps and assess when and if you really need to add anything new. Think about creating a help center. Parents are stressed to the max right now, as you may well know yourself, and many of them feel like they're running the one-room schoolhouse for children of all ages. Creating a central repository for your calendar, lesson materials, student independent work, and other resources is helpful to everyone. When someone asks you a question, you can point them to one place for help. And when parents can't remember what their child needs to study or decide that they need some additional support, they only have to go to one place. Above all, just relax and keep a sense of humor. There are going to be missteps along the way, just like in your regular classroom. With good communication between teachers, parents, and students, we will all survive our transition to the virtual world of education. And having pets around doesn't hurt either. So let's summarize what we've learned in this module. You want to be purposeful when assigning work that will be completed asynchronously, as students will have a limited amount of time to do the work. Whether a student works with you online or offline, make sure that you maintain the same learning expectations. Make a plan for an online, a hybrid, and an offline approach so that all of your students can access the mathematics. And make sure you provide executive functioning supports as well as academic ones. As we've said before, work as a team on getting this done. It'll be very helpful to have colleagues that you can run ideas by and keep in touch with one another to see what's working and what isn't. So on behalf of the Rhode Island Intensive Math Intervention Project, I'd like to thank you for tuning in for this series. We hope that you'll find these ideas helpful in your classroom and we would love to hear from you what's working with your kids. Be sure to check out our website, rhodeislandmathproject@gmail.com, for more resources and information. Thank you for all that you do with students each and every day. Take care.